moderator, Linda Becker, the associate publisher and editor of Process Cooling Magazine. Thanks for joining us. Now, here are a few words from our sponsors. Harmsco Filtration Products offers a broad selection of high-performance stainless steel filter housings featuring the Hurricane line, whose intelligent design saves up to 20% in energy, up to 3 times the throughput between servicing compared to generic housings. Harmsco offers the largest selection of NSF-listed filter cartridges from antimicrobial media, which can inhibit the growth of Legionella on the cartridge filter, to submicron for high-purity applications. For economical, high-performance solutions to your filtration challenges, call Harmsco or visit harmsco.com.
Technologies manufacturer of Marley Cooling Towers is a strong advocate for implementing effective water management plans. In addition to cooling towers, SPX offers the Marley Guard Chemical Delivery System, a robust panel that delivers treatment agents and monitors cooling tower water quality. Water management systems are crucial to the health and efficiency of cooling towers. Learn more at spxcooling.com.
At Evoqua, we've got millions of people relying on us to make water safer, to offer best-in-class solutions for superior returns. In the factory, at the faucet, for our rivers and streams. And that takes technology, service, and expertise. With a 100-year heritage of innovation and reliable performance from trusted brands, at Evoqua, we're ideally equipped to care for the world's most precious resource. Prepare for the next generation of global water demands with the world's water treatment leader. Visit evoqua.com. Evoqua, transforming water, enriching life.
Thank you to all of our sponsors for making today's webinar possible. Today's presenter is Paul Pecorius, the President and CEO of Pecorius & Associates. A water treatment does not sell any chemicals or equipment and is not affiliated with any water treatment supplier. Paul is also a former columnist for Process Cooling Magazine. Paul has more than 50 years of experience in cooling water, boiler water, and reuse water technology, specializing in corrosion, scale, and microbiological problem solving, treatment selection, and system startups. He has extensive knowledge with expertise related to Legionnaire's disease, relating to investigations and Legionella control in cooling and potable water systems. Paul is internationally known for his work in problem solving, development of an effective scale prediction method, work on water reuse, and Legionnaire's disease investigations. Don't forget to submit your questions, and later in the program, Paul will address as many as he can. Today's event is being recorded, and it will be archived on processcooling.com. And now, without any further ado, I am excited to turn it over today to our presenter, Mr. Paul Pecorius.
Thank you very much, Linda, and I appreciate your introduction. I do hope that we could cover a lot of different subjects today, and those particular subjects, of course, are identified in our first slide. As you can see, there is a variety of different things that we're going to be looking at. To me, there's some emphasis that we have to place on starting up a number of different programs and identifying various things. But hopefully, the information that we're going to be providing today is going to give you some experience that we have had and knowledge that we have in regard to the industry, and hopefully will help you make better decisions in what you're going to be doing in the industry. Of these particular subjects that we're going to talk about today, I want to emphasize the fact that this information really applies to all types of industries. I mean, large industries as well as small industries, in HVAC as well as nuclear power plants. So it's a technique that can be used very effectively and provide very effective information relative to the use of your cooling water treatment program. So from the standpoint, the next slide shows the different type of cooling towers that we are dealing with on a regular basis. Large industrial plants, whether they're nuclear power or fossil fuel, whether they're chemical plants or refineries, or whether they're HVAC systems that we'll be dealing with. So the key here is to take a look-see and see what do we actually have in the next slide to develop a first-rate water treatment program. That first-rate water treatment program is got to be a very, very important step in developing what we consider to be and what we've identified as the first-rate cooling water treatment program. And that is, you need to know exactly what you have in the way of equipment in your cooling water system. So the first thing that we have to do, of course, on it is gather the information that we need to have available for us to help make that decision. When we're dealing with this initial information, this includes, of course, everything that is contacted by the cooling water that's circulating through the cooling tower system. Of course, in a cooling tower system, basically we have two components. We have the cooling tower, and we have heat exchange equipment, all tied together with piping. That piping, of course, is ideal. It's got to carry all of the water treatment problems around and round, and that's what it does. Carries problems around throughout the system, but also carries the water treatment chemicals that you're applying. Remember, you really are not treating the water. What you're doing is using the water to carry the inhibitors to those areas that want protected, which of course could be the heat exchange surfaces on a major power plant or a refinery or even an HVAC operation. It could be the cooling tower itself, depending upon the construction of the cooling tower. What we have here is I'd like to identify a methodology or a program that we developed, the MEOW program. And that MEOW program is a very, very critical aspect in regard to coming up with a first-rate water treatment program. That particular program involves 4 different aspects of the MEOW program. As you excuse me, I have a little bit of a cold. That utilize the MEOW program procedures. The M stands for the materials of construction that are contacted by the cooling water itself. The E stands for the equipment design. The operation of the system is what the O stands for. And last but not least, we're dealing with what the cooling water quality is. So these are the things that we have to look at. Next slide, please. And that is that the materials of construction we're dealing with in all cases are mainly metals, because that's what we're dealing with in regard to corrosion problems. So we're dealing with mild steel particularly, which is sensitive. That could be the piping, it could be heat exchanger tubes, and it could be copper. The galvanized steel is not normally tubes in a heat exchanger, but it is a part of a cooling tower. Stainless steel can be, of course, part of the cooling tower. It could be a plate and frame heat exchanger. So consequently, these are the things we have to look for in your cooling water system. You have to identify these. And don't forget these combinations where we have copper and mild steel, where we have galvanic couples. We want to make sure that we have things like that pretty much covered in our treatment program to be able to minimize or try to stop as much of that as we can, which is known as galvanic corrosion. And last, it would be nice to have titanium in many of the tubes of heat exchangers, but it's quite expensive. But it can be very affordable. Titanium is resistant to most every type of thing that we can think of in regard to cooling water systems. So consequently, we have that. Now we need to get to the next one, and that is the E. The E stands for, of course, the equipment. It's the design of the equipment. The equipment, is it you got water going through the tubes, or do we have water going from the shell side? The shell side is terrible in most cases because the velocities are low, there's fouling tendencies, etc. So that means that you would say, I'd have to have a much greater amount of dispersion in my treatment program to be able to handle that fouling condition. That would be a place for biological growth, so you need some better biological control. So, and if you could have the combination of both, which is done in refineries and chemical plants, that makes it even more difficult for your treatment program. But it does indicate to you that you are going to be dealing with possibilities of fouling conditions. Jacketed vessels are prone to fouling as well. And don't forget the plate and frame heat exchangers if that's being utilized in your system. Last but not least, of course, is the cooling tower fill itself. And can I have the next slide, please? There's an example of what the fouling can occur in a cooling tower in this fill. And if that is the case, that's going to not only contaminate the rest of the system. Remember, the cooling water is carrying not only your water treatment program to wherever it has to go and protect all that equipment and water contacts, but it also says you can carry some of these problems around, and those problems, of course, can drop out in the heat exchangers and jacketed vessels and what have you. So you got to keep the film pack fill in the cooling tower clean as well. Could I have the next one, please? This particular slide is the operation of the cooling water system, and that is what type of operation do we actually are encountering here? Is it continuous 24/7, or is it dealing with, of course, periodic shutdown? And a periodic shutdown, how does that impact on my water treatment program? If we want to really have a really good first-rate cooling water treatment program, you've got to consider the fact that it is maybe shut down over weekends, shut down over periodically. It could cause, of course, deposition during that time. How it impacts on your water treatment program is it usually requires higher dosage levels during those periods of time. In fact, it's better to carry a higher dosage level when you do have periodic operation. What's a higher dosage level? 50 to 100% higher in many cases, particularly for deposit and microbiological control, but it also could be for corrosion control. Another area we have to look at is, of course, the scaling tendency of the water. What is the operation here in regard to the maximum water temperatures? And that is because we're looking for potential scale. And if that scale is such that it's going to come out on a major heat exchanger, that's a real serious problem. So that means you have to address the scaling inhibitors that you're using to make sure they're compatible, not only with the other inhibitors, but also it's very important that it is addressing this type of scale that occurs. Calcium carbonate is the most common one, but if you're using a phosphate treatment program, then you have got calcium phosphate. It has to be controlled. So scale is a very, very important criteria for a first-rate cooling water program. But it addresses, of course, what's the maximum water temperature. Keep in mind, however, the operation of all of this equipment. If you're a refinery that's got one heat exchanger that is operating at very high temperatures versus the rest of the heat exchangers in your plant, the question is, why let that heat exchanger scale up, and you're going to have to descale it periodically, rather than spend the money to be able to go to a higher scale inhibitor level to control that just one small heat exchanger when the rest of them don't require that high level. Excuse me. And it's another aspect that we look at, and that's the minimum water velocity. So we need to know is it 1 foot per second or less type of thing. That is a big fouling tendency, like we showed earlier on the cooling tower fill. That can happen, of course, in the heat exchangers as well. Then, of course, the other is the facility capable of actually monitoring the water treatment chemicals programs. A major industry normally will have somebody on staff or a water treatment service company that is actually providing that type of service. An air conditioning type system, on the other hand, may not have any capability on the staff and only has periodic, like once a week type of thing, or sometimes once a month type of thing of testing the water. Not very sufficient. You got to have much better control than that. So you find out what your monitoring capability is, and then choose the program that is more flexible in regard to variations. Because if you have variations in the water quality and in the water treatment program, can actually minimize the problems that can occur by making sure that you have the proper levels of your scale inhibitors and corrosion inhibitors and biocide. Now, what what is the dependence on the water treatment service company is what one point I brought up here. And sometimes what people look at and say is, well, I'm not sure I want to depend upon them 100%. Well, that's okay. Then you develop your own treatment monitoring the program so that you make sure that you know what that operation is on your cooling water system. But don't depend upon somebody to say, okay, I know what's going on in your system. And if they don't know what's going on in your system, then find out what's going on in your system from the standpoint of the operation. So from the standpoint of going from the MEO, to the next slide, which of course is the last one of the MEOW program, and that is the W. And the most important thing to consider here is the fact it is what water are you actually looking to test. The water that you want to test is not the makeup water. It's what you expect that's going to be in the tower water, because that's what's going to be contacting your equipment when you're cycling up your cooling tower system. So the net result here is to say, keep your attention to the cooling tower water and what the variation may be, or what level you'd like to carry in your cooling water system. If you want to carry 3 cycles, 5 cycles, 7 cycles, the thing you have to do is, okay, what was the water quality there, and what type of treatment do you need? Do I need acid to reduce the alkalinity? Can I use inhibitors that'll do that type of thing? So I need to identify what that scale potential is. If that scale potential is such that the calcium level and the alkalinity is too high, then you need to be able to modify your treatment program to be able to offset that. I've included one point here that some of you may not be aware of, but by running a PSI, which is calcium alkalinity relationship mainly, PSI is standing for Practical Scaling Index. It actually now has been renamed Pecorius Scaling Index. It's similar to the LSI and the RSI. A lot of people still are using the LSI, which is absolutely incorrect and gives you incorrect information because it uses pH in the water, and you don't need to do that. You can't use pH. You got to use the calcium alkalinity relationship and to determine what the real potential is for scale. And then you adjust your treatment program and your water quality to be able to prevent calcium carbonate or calcium phosphate or even calcium sulfate from occurring. The other one, of course, is the corrosion potential. What are the TDS and what are the chlorides? Those are the two most important areas that we look at, particularly the chlorides if you have, of course, stainless steel. Then we have the biopotential. To me, biological control is absolutely one of the most key areas in any type of treatment program, particularly a first-rate cooling water treatment program. You need to have good biological control, which will reduce corrosion problems. It'll reduce some scaling problems. So consequently, it will improve operation of the equipment. So there's a lot of things that you have to look at to say, okay, let's make sure we have good biological control, whether it's using oxidizing biocide along with non-oxidizing biocide or just only an oxidizing biocide. And then we'll be talking a little bit about what we're dealing with. But now you can see what you need to know about your system. The MEOW program says, here's what you have to find out. Now you can actually select the water treatment program to protect your system. So let's take a look-see at a couple examples, or real quick ones. But a chemical plant has multi-metals, several heat exchanger designs. That means water through the tubes, water through the shell, operates 24/7 in continuous monitoring. What type of thing do you have there? You have to have a good water treatment program to be able to cope with multi-metals in the system, and also the design of the heat exchangers, both for fouling potential and for continuous operation and scaling tendency and corrosion. And you should have continuous monitoring in a chemical plant so that you minimize that. That goes true for refineries as well as chemical plants. But in this case, it would say, okay, I have to have a good corrosion inhibitor because I have multi-metals. Is that for mild steel or copper alloys? then I have to have a good dispersant, which says that I have to have a good dispersant to maintain less fouling, not only in the cooling tower but also in the heat exchangers, and that continuous monitoring will provide you that input as to how effective that program is. In a power plant, in this case, we're looking at another example. It's got copper alloy tubes, water through the tube side always, operates 24/7 and has frequent monitoring. A power plant has a lot of protection built into a system. Sometimes its heat exchangers almost all of the heat exchangers are copper alloys, not copper per se, but copper zinc or copper nickel, and that's an excellent minimized corrosion problem for copper. Even though it could use a copper corrosion inhibitor depending upon what the conductivity is, and depending upon what the chloride levels are, etc. From the standpoint of water is always on the tube side, means that you have less fouling, and it's usually got high velocity to the point where it actually gives you really good scouring action through a power plant. So a power plant, in this case, says you need a little bit of copper corrosion inhibitor. If there's any mild steel around, you need a little mild steel, but you probably don't need any. You can actually get by with very little treatment program for a power plant. Air conditioning is a lot like a power plant, except that it's periodic operation. It's infrequent monitoring, and they can have stainless steel plate and frame heat exchangers tying in with the chill water system. But air conditioning requires a lot more biological control, a lot more scale control, because it is periodic operation. Frequently, your machine shut down. So consequently, that's the difference are how you use the MEOW program to say, here's the type of treatment program that I could come up with based on knowledge of what's in the system. Have the next slide, please. Let's talk about new systems. Talking about how do you start up a new system? Well, starting up a new system is a critical area for any type of cooling water treatment program. If you want a first-rate cooling water treatment program, you've got to be able to find out, number one, what is the condition of the water surfaces contacted by the cooling water? Do you need a corrosion inhibitor to be able to contact those surfaces? Yes, you do. The corrosion inhibitor, if it's mild steel, you have to make sure that the corrosion inhibitor can get to those surfaces. That means it's got to be clean. If it's dirty, on a new startup system, a new system may have just oils and greases and a little bit of rust. But don't assume that that's all it has. It could have, of course, a lot more corrosion that do require not only the cleaning by degreasing or only using water treatment, or it could require a more strenuous type of cleaning program just to make sure you got the surfaces clean, so that you actually can allow the corrosion inhibitor to get into those metal surfaces and stop the corrosion that may occur due to the corrosivity of the cooling water. What else is there? Disinfection. A new system should always be disinfected to eliminate two types of microorganisms. One is those that cause corrosion on mild steel and copper alloys and other alloys, and pathogenic ones, particularly Legionella. But any type of biological control, because in the process of getting construction of a new cooling tower water system, there is sometimes dead legs there, sometimes there's water that's been left in there for a period of time, but that could be contaminated. And then when it starts up with a regular treatment program, you could have a lot of biological contamination, and that could be the source of corrosion and even pathogenic organism. The key here is you must disinfect your new water system. Usually using high level of chlorination, bromination. Both of those work very, very well. Chlorine dioxide works quite well as well. And the key here is to have good dispersion to be able to make sure you get rid of all of these corrosive organisms and all microbes, and that you can actually kill those. Follow that, of course, once you clean the system up, You must double the inhibitor dosage to the point where you actually are at the can start up for about one week or so with double dosage level, so that you actually are starting to protect your system very effectively. The key again is start your monitoring as soon as you start up the system. Don't wait until things get uniform. And when a new system starts up, it doesn't have much load. Because it doesn't have much load, what happens? The thing that happens is that the water is not evaporating as much in the cooling tower, so you have perhaps a much more corrosive water condition. So you've got to adjust your inhibitor. If that monitoring says I have corrosion rates that are a little bit on the high side, then I better get my inhibitor up there to make sure I'm stopping that corrosion. It probably wouldn't give you the scaling tendency, but on the other hand, it could mean that you do have some contamination with biological. But the key here is probably start your monitoring so you can determine what results are actually starting up right now with a new system. Don't wait for, say, a month or 2 months or 6 months and then start your monitoring. That's too late. It could have started, any of the corrosion problems and any of the bio problems could have started already, and that would give you the trouble. So keep that in mind for starting up a first-rate cooling water treatment program. That's the next slide, please. When we're dealing with the startup of a existing system, now we're dealing with, of course, something that's very interesting. Sometimes people say, well, we'll just get started with what we have right now. The existing system, depending upon if you take it over from somebody else, could have a lot of scale and rust and biofilm present. And if it does have that type of thing, this has to be removed, because your treatment program is, remember, the water is carrying the inhibitor program to the areas you want protected. If you can't get those areas clean enough so that the inhibitor program can get to the surfaces, it's not going to do its protection of your equipment. So you got to make sure that the existing system is devoid of scale corrosion. Does that mean that the owner has to chemically clean it? The answer is yes. Does he want to do that often? No. So you have to be able to identify the fact that there is a potential here. If it's very critical, if you don't remove this, you're going to get in a continuous corrosion and scale in your system in biological. So it's very important. So that you must get those water surfaces clean to be able to make sure that we are dealing with absolutely what we have to do with keeping systems clean. Again, we're dealing with disinfection. Excuse me, wow, got a little bit of a cold here. I apologize for that. Every existing system in your startup should be disinfected, because that is where we frequently find biological problems have occurred or are occurring, and the net result is that you're going to have corrosion problems and probably pathogenic material present, microbes. So you must disinfect it against high dosage levels of chlorine or bromine, again, making sure it matches your treatment program. But on the other hand, the other thing that you have to look at, of course, is okay, what are we trying to do? We're trying to minimize the potential for any corrosion in microbiological organisms that could cause fouling problems, it cause corrosion problems, and biological problems, and microbiological pathogenic problems. Monitoring should start again right away. Determine if the water treatment needs to be changed. What do I mean by that? That means if you get started with a program and it shows that it's not doing its job, change your treatment program. That's how you get a first-rate cooling water treatment program. You don't stick with, say, one treatment program because this is what I think I should start with and this is what will work. Make sure that treatment program is fitting the water quality and all the materials of construction that you have in your system. That's what we were talking about before. That is to use the MEOW program to help you develop that particular methodology, and then you can determine if that treatment program has to be changed. Does it have to have more biological control, more corrosion control? Does it have to have more scale control? All of these things, of course, are necessary to be looking at to determine if and what's going on. But you got to monitor it to start with right away. Now, I should probably mention monitoring can be done several ways. One, of course, naturally look at the heat transfers and what you're getting on heat transfer. But the other aspect is how can you determine what the corrosion rate is? Corrosion rates can be measured several ways. Wow, excuse me. Several ways. Corrosion rates can be measured several ways. One is the easy, low-cost corrosion coupons. But what does a corrosion coupon do? You put a corrosion coupon in a system. It's in the system for, 30, 60, usually 90 days. And you take it out after 90 days to determine what's happening in your system for the last 90 days. Oh, my gosh almighty. If you're waiting 90 days to be able to determine whether your treatment program's working, I would imagine if it's not working, you're really in trouble. And my feeling is I like to use some more rapid corrosion monitoring technology. One of the ones that, of course, that are used quite effectively is the linear polarization, and that is it's a corrator that can be used, and that corrosometer is a very excellent technique. It's called linear polarization, and it's an instantaneous corrosion rates. So with that instantaneous corrosion rates, what you do have, of course, is a need to be able to say, I think the corrosion rate is doing good. Then, of course, if it's not, you can adjust your treatment program very effectively. But that can tell you what's happening right now, today, right this very minute. Just push the button in the instrument, and it tells you the corrosion rate. Not corrosion coupons that'll give you 90 days later, where your system could be actually a disaster. So consequently, and that has happened in many cases, believe it or not, where people have done that type of thing. But because it's cheap to be able to take a corrosion coupon and use that. So the net result is use something that is very much more effective in monitoring corrosion. Now, biological control, you can use dip slides, etc. You could use any type of the new technology to being able to come up with water quality type of thing, and how much bacteria is there. So you've got to make sure if you're identifying any corrosive bacteria, you want to make sure that that's got a good biological program to take care of what you've been doing there. Anyway, could I have the next slide, please? Monitoring bacteria and Legionella. Okay, what are we trying to talk about here? A couple things to do. We are currently taking water samples to do both our total bacteria testing and our Legionella testing. So that's good. That's the process that has been developed and has been in place for some time. You notice I'm emphasizing water samples. The standard procedure uses water samples. So my question, of course, is why are we using water samples? It could be misleading. What do you mean by misleading? Well, if you're taking a water sample and it says I don't have any total, I have a very low level of total bacteria, even a low level of Legionella, the big question, of course, is says, wait a minute. If I have biofilm in my system, biofilm, that's the biological film that is created by the microbiological organisms, and that's where many of these organisms like to live, the corrosive ones particularly. And in the past, we've monitored we've monitored corrosive bacteria by taking samples of the biomass, but not for total bacteria or for Legionella. We should actually be taking I consider to be a biomass and determine what that biomass is. So, but the problem is we don't really have a standard developed as yet to come up with a technique to be able to take, a certain amount of biomass and then use that. Now, we've developed what we call a biofilm coupon, and that's a possible method to use. It's similar to a corrosion coupon, 1/2 inch by 3 inches, but it's made out of stainless steel wire mesh, and that stainless steel wire mesh acts as a place for the biofilm to grow, so or it'd be trapped and grow. So we utilize that particular biofilm coupon to capture the biofilm, and then we take that and we knock off that biofilm in some sterile water, and then we actually do the testing of the biofilm total bacteria, and then now we're coming up with what is present in your system. Remember, biofilm is the key problem. The water is actually carrying the bacteria, and those bacteria, if they don't settle on a surface, are really not a serious problem. Let me use that as an example. That is, if you have a floating or a dispersed bacteria in your system and it's not attaching to any of the surfaces and building up biofilm, that doesn't give you a problem. Okay, that's terrible. But anyway, apologize again. But so what do we do there? What we do there, of course, is to say, wait a second, what we need to do is to make sure that we have some method of being able to attract the biofilm and then measure the biofilm. What levels you come up with is you got to look at standing up some sort of procedure. But corrosion monitoring, we've done this in the past for years. But why don't we do this for total bacteria and biofilm? So those are the net results of what we're actually been talking about. So let me go on to the next slide, if I may, please. And we're talking about now what's the future of cooling water treatment. It's going to be the total elimination of phosphate. We're in the process of doing that now. There's new inhibitors that are on the marketplace today that are total organic product, no phosphorus at all. Why are we doing that? Because phosphorus is looked at as being a nutrient for microorganisms, particularly algae, and it's a cause of phosphate fouling problems. So the net result is using organic treatments. Are they working as well as the phosphate treatment? Yeah, the reports are pretty good. These are mainly organic treatment programs, but that means that they are very, very effective, and they can be, depending upon what the limitations are of those particular treatment programs. In all cases, if the limitations are such that we are to the point where we're not doing as good as we did with the phosphate, then the treatment program is not very good. So you got to again back to monitoring. Another area of future which I'd like to identify is non-chemical treatment. I see down the road that there will be non-chemical treatments being used, either standing alone or in conjunction with chemicals. Now, if there are non-chemical treatments, we've changed the terminology now to physical water treatment. Is there any physical water treatment that works real good? There's two sponsors that we have today that have filters. Absolutely every cooling tower system in the country should have a filter, because that really is reducing reducing your fouling problem, and reducing corrosion problem. It's reducing scaling thing indication, and it could reduce it by as much as 10 to 15% of your chemical treatment cost. So, to me, a non-chemical or a physical treatment program filter is essential. How about the non-chemicals, the physical treatment program that actually it's claims to control scale and biological? Yes, there are a couple of them that work within a certain parameter. You have to have a certain parameter in which they will actually perform. And I can see that most large industrial plants probably will never use the non-chemical or physical water treatment for scale and corrosion control or biocontrol. Air conditioning systems, yes. that's probably the best place where that's going to be applied. Sometimes, of course, with chemicals, some are adding corrosion inhibitors to supplement the scale and the biocontrol techniques. But again, as I say, filters are critical and should be a must in every cooling tower system in the countryside, even the big ones as well as the little ones. And I realize they cost money, but they actually have good return. And back again, what we're talking about is the monitoring essential. We have to have a good monitoring in all of our treatment programs to develop a first-rate cooling water treatment program to find out, is it working? If it's not working, modify it, change it. But keep on top of it. The key here is rapid monitoring, understanding of what you need when you have a lot of different things in your system, and the MEOW program helps you do that. Once you do that type of thing, you can come up with, I believe, a very effective treatment program. And we can call it the first-rate cooling water treatment program. And monitoring is one of the key areas. So with that, I'd like to have the next slide, and I want to thank you all for your attention, and be glad to answer any questions.
Thank you, Paul, for a great presentation. We have a number of questions that have already come in, so I'm going to go ahead and hop in and just give you the first one that I see here. Are you seeing an increase in web-based monitoring, like internet-based technologies?
What kind of technologies?
Web-based technologies are those that are basically managing remotely through the internet?
Yes, I'm seeing a greater increase in that. Correct. That to me, I think is one of the things in the future that's going to be occurring. Does that help?
Yes.
Or didn't that answer the question?
That answered the question. So the next question is,
okay.
should pH testing and other types of tests be a part of the program? Is there an ideal water characteristics for where the system would be best suited?
Everything depends upon the MEOW program as to what you have in your materials and construction and operation of your system as to where that pH should be. pH is not as really very important in a cooling water system, even though there is of course directions by various people to say this is a pH that they'd like in their cooling tower, cooling water system. Usually the PSI or determining what the scaling tendency, that's much more important than what the pH is. pH probably is relates more towards potential for corrosion. So the net result is, yes, you want to have an alkaline pH. In most cases today, a pH is above 7.2, 7.5, even up as high as 8.5 are what pHs are being carried today very effectively with the scale inhibitors, dispersants, and corrosion inhibitors. So the net result is that, yes, I would say you should control pH in the alkaline side, and but I would not depend upon pH as much as particularly for scaling tendencies as I would for, say, the PSI, which we talked about before as being scaling. It tells you how much scaling potential there may be.
Okay.
I hope that helps.
Yep. You had mentioned using filtration for the cooling towers. Can you talk a little bit more about the types of filter you're talking about with relation to cooling towers?
Oh, yeah. Everything depends upon the type of materials you want to filter out. You know, a very, very light, fluffy type of deposits or a sediment that you may have in your system, like biological, you have to have a pretty good filter to be able to remove that material. Excuse me. Wow. Sand filters are very good, but you can get some real good, high efficiency sand filters type of thing. The Vortisand is a good example of that type of thing. There is of course, if you're dealing with high particulate matter, you can actually deal with a cyclone type of filter. It's actually a removing agent, but again, it depends upon what is the characteristic of the material that you'd like to have removed. Then you identify that particular filter, which will actually remove that type of particular material. I like to use one that covers a variety of things. So you want to make sure you're covering the suspended solids coming by air, and maybe even taking out biological type of thing, which is good. And then, of course, at the same time, it would be good to be able to say it's going to reduce my water treatment chemical cost by 10, 15, 20%. And that's exactly what you'll see. So keep in mind that it depends upon what that particular batter is to be able to choose the proper filter.
Okay. We have another question following up on filtration, which asks, how much of the water flow should you be filtering? Would you recommend side stream filtration? And also, what micron level would you recommend at?
Okay, normally we look at a 3 to 5% is circulation rate of the circulation rate. The circulation rate in a cooling water system, say if it's 10,000 GPM, then you should have a 3 to 5% of that range as to what you should have for filtration. Another technique to use is if it's a depending upon the volume in the system and the design of the system, you might say I have to really filter the entire cooling water system 3 to 4 times a day, and that's the type of thing you need. From a micron standpoint, again, it's back to what you might have. You may have to go to 5 microns, 10 microns, yeah, but on the other hand, you may have to go down to 1 micron depending upon what you're trying to filter out. So the micron size is more dependent upon what you're trying to get out of the water. That helps?
Yes. What are some of the risks in developing secondary microbiological regrowth after using biocides?
Well, a lot of people say that some biocides, particularly non-oxidizing biocides, those are not the oxidizers like bromine, chlorine, and chlorine dioxide. They don't really get resistant microorganisms to that type of bacteria, that biocide. I think if you just kill the ones that it works with, and you got new ones that come into play, rather than actually having the biocide itself deteriorating. But it is a good idea. It's always a good idea if you're using only non-oxidizing biocide to switch. You should have 2 different ones so that you're back and forth on a regular basis, just to make sure that there may be some resistance that may be built up, but so the other biocide should be able to take care of it. So that's what I would recommend. I'd recommend for non-oxidizing biocides, I would recommend using 2 different ones. On the other hand, if you're using an oxidizing biocide, then you can use an oxidizing along with a non-oxidizing. Remember, oxidizing is burning underwater, is what I call it. And burning underwater means that, of course, that you're really killing the bacteria in the water. And it's a strong oxidizing agent, just like bleach. And it is bleach often. So nothing resists that. Everything is killed there, and so is the nutrient, which is, of course, an advantage using oxidizing biocide. I hope that helps.
Okay. Can you discuss the importance of passivation of any new heat exchangers, whether they're copper and steel, and all the associated transfer piping?
Very important. Very important. That's an area that really has not been. It's been discussed with quite extensively over the past number of years, but recently has not been discussed at all. But any type of new heat exchange equipment or chemically clean heat exchange equipment, the tubes should be what we call passivated. That means that, of course, either you go through a special chemical treatment that actually is establishing a good protection on that clean metal surface, or what it is, it's a chemical treatment program that is directly compatible with what your standard treatment program is going to be, and that will be protecting that heat exchanger at the very beginning. So passivation at the very beginning is very, very important and very good.
Okay.
That helped.
Yes, that did help. I lost my question there for a minute. Can you, without necessarily naming any specific manufacturers, can you recommend some things to look for in an instantaneous corrosion meter like features that you want, things that would make it be more useful, more helpful?
Yes. Well, there's a number of people. Metal samples. You know, I, the name of those things are Corator, and a number of manufacturers that have a Corator type. If you refer to linear polarization, that'll pop up, of course, the type of corrosion corrosion instrument that you could use to give you rapid information. But metal samples have samples. You have Rohrbach has that. You have I can't remember all the other, but you should be able to come up by going on the internet, Google, and being able to come up with linear polarization corrosion measurement of water, and that should be able to pop up a number of the manufacturers for you.
Okay. What is your opinion on performing specific Legionella testing versus TBC only?
Well, that's an interesting question. The current accepted method, of course, is using a culture, and that's exactly what it is. It takes a period of time, 10 days, to be able to determine what's in that particular sample. That's the current procedure. PCRs are I think, a very good technique. That's also known as DNA, and that is it gives you very rapid information, but it'll give you usually dead microorganisms that kept as well as live. So you could have Legionella present that have been killed already, that are present, that would show up in PCR, but would never show up on a culture because they were dead. So look at what it can provide and what the limits are. So I think you can use both of them effectively. Like I say, the current accepted standard method is using actually culture.
Okay. Can you describe some of the key issues involved when using gray or recycled water for cooling tower makeup?
Oh yes, there's probably three different things that you have to look at. Number one is the ammonia content, particularly if you've got any copper alloys in your system. If there's ammonia there, you don't want ammonia. You got to get rid of the ammonia because that'll attack copper alloys. The other would be phosphate. If there's phosphate coming into by way of the water, the recycled water, what you have to do is make sure you don't have too much phosphate. It may contribute some scale as a corrosion inhibitor, but you don't want to make sure that it's not too excessive. And so consequently, phosphate is another one. The last one would be chlorides. If you've got high chloride levels, if you've got stainless steel present in your system, again, remember how the MEOW program can identify what materials you have in your system and what's going to be in contact with the cooling tower water. And if you do have stainless steel and the recycled water, the recycled water has got a lot of chlorides in it, you may not be able to use that particular water. I hope that helps too.
Oh, okay. The advice that you've given today in this presentation, would it also apply to closed loop systems such as chilled water systems?
Well, chilled water systems are similar to this, to a cooling tower system. You've got to make sure it's clean and you've got to make sure that the inhibitor program is actually high enough to be able to give you good protection. If you have a different type of treatment program for chilled water system, closed loop systems, if you're dealing with a nitrite program, then you have to make sure that you don't have a bacterial problem. So that there's other issues that you have with it, but one major issue is to make sure is that the tubes are clean when it's been installed a new facility, or if you take over one, you have to clean it, like I say, like an existing one. So a lot of that still applies for a closed loop system, but they are a little bit different, and consequently you have to address those differences between the two.
Okay. Can you talk a little bit about how conductivity affects water quality in cooling towers?
Conductivity increases corrosion. The higher conductivity, the higher corrosion there is of the water. So you have to have greater corrosion inhibitors as the corrosion inhibitor levels as the conductivity increases. So it's really something that you have to look at relative to do I have enough inhibitor to deal with the level of conductivity that I'm dealing with right now that's coming in by way of the system and what's concentrating in the cooling tower system. So the two work together, conductivity and corrosion. And you know, if you have high conductivity, you have a very corrosive condition that can occur in your cooling water system. So therefore, you have to adjust your corrosion inhibitor to be able to make sure that you are protecting your equipment. And I hope that helps.
Mm-hmm. Returning back to filtration, in your experience, have you experienced that finer particles have been an issue in cooling water systems, or is it larger particles?
It's smaller particles. So both of them can give us difficulty, but most of the time it's the smaller particles that are giving you more difficulty because they tend to get accumulated in various portions of the system. Heavy particles, of course, are they settle in the basin of the cooling tower, and they're easier to take out. But both of them have problems. But I would say, if anything, the lighter, smaller, lighter weight particle is much more of a problem than the heavier ones. And I hope that helps.
Mm-hmm. We're getting short on time. I want to make sure I get a good question here. How much does the difference in quality of water that you use for your makeup water to refill your system versus what you fill it with affect being able to keep it properly treated?
Could you say that once more?
Sure. How much does the difference in water quality that you use to fill a system make? How much of a difference does that make with being able to keep it properly treated? Like, for example, if you use very dirty water versus maybe fresh, pure water from the city, like.
Well, if the ideal thing, of course, is to have good quality water coming in your system. You don't want dirty water, but unless you have filters again, and you have a proper chemical treatment program to be able to handle it. But from a standpoint of variation in the makeup water, again, you need good clean water. But if you have a variation in mineral content, then that could impact on your treatment program. If you get into more scaling tendency or more corrosive tendency, like if you actually get more chlorides, like I mentioned, that could give you more corrosion problems. So if you get into more hardness water, that gives you the scaling problems. So you got to depend upon what that water quality change is going to be and how it could impact the total water in your cooling water system. If you're working with periodic addition of a different water quality, but only periodic, if it's only maybe a few hours a day, that may not impact much at all, because remember, there's a volume of water in the cooling water system, and to change that over quickly would take a long time for the makeup water to be added that would modify that particular water quality. So if it's only for just an hour or two type of thing, you probably won't see much change.
Okay.
I don't know if that answers the question.
Well, I think it does.
Glad to do it.
Thank you, Paul. Unfortunately, that is all the time that we have for questions today. I will work with Paul to see if we can't get some answers for those of you that I wasn't able to read your questions. I do apologize that I wasn't able to get to all of them today. I would like to ask everyone to please join me in thanking Paul Bokorius for his great presentation, as well as our sponsors, Evoqua, Harmsco Filtration Products, and SPX Cooling Technologies. If you have any additional questions or comments, please don't hesitate to click on the Email Us button on the console. As you exit today's webinar, please take a couple of minutes and complete our survey. We strongly welcome your detailed comments. You can visit webinars.process-cooling.com for an archive of this presentation, as well as information